Bismillahirrahmanirrahim. Nahmaduhu wa nusalli ala Muhammad Rasulullahi Kareem. This problem is related to partial differentiation of differential calculus. If x square upon a square plus u plus y square upon v square plus u plus z square upon c square plus u is equal to 1, prove that del u over del x whole up square plus del u over del y whole up square plus del u over del z whole up square is equal to 2 times x del u over del x plus y del u over del y plus z multiplied by del u over del z. We have to prove this by using this relation. From the given relation, we observe that u is function of three independent variables x, y, z. So I write the given relation: x square a square plus u plus y square upon v square plus u plus z square upon c square plus u is equal to 1. And now we will differentiate this equation with respect to x partially. So I write this: differentiating both sides of the given relation partially with respect to x, we get, on differentiating this term, we can consider 1 upon a square plus u is a function and x square is another function. So apply product rule on these two functions. On differentiation x square we get 2x, and second function as it 1 upon a square plus u. What when we differentiate, apply formula, first function as it differentiation of second function. 1 upon a square plus x is the second function. When we take it to numerator, then its power becomes -1, and on differentiating we get -1, and a square plus u is -1. What it is not x, so differentiate it with respect to x is by chain rule. We get differentiation of a square is equal to 0, and differentiation of u is del u over del x. Now we will differentiate another term. If any problem in this differentiation of this, I show it clearly on the other page. Differentiation of only this term, x square upon a square plus u, I considered it is as x square and 1 upon a square plus u. And also I write this in numerator, then degree of this 1 become to -1, and consider it is as a product of two function, first and second. And now differentiate by product rule. Differentiate first, it becomes x square, and write it as it a square plus u to the power -1 plus and write x square as it, and differentiate this value. On differentiating this value, we will I write it in detail. 2x, if we want to convert it in positive degree, so take it to in denominator, plus x square into consider it is as a x, and apply this formula, and x to the power n minus 1, so we will get -1, and consider it as x. So n minus 1, what it is not x, it is a square plus u. So we should differentiate it, we must differentiate it by applying chain rule, a square plus u, and we get 2x upon a square plus u and plus x square and minus 1 this, and a square plus u whole power minus 1 minus 1 minus 2, and differentiation of a is 0 and u is del u over del s. In next step we will see that this sign convert to minus because minus 1 multiply here, so we get 2x upon a square plus u and minus x square, and this becomes positive on taking it to denominator and multiply to del u over del x. This is value of this. So I write it here. So I write directly here. So I can write this value because I solve it here in detail. So I write here 2x upon a square plus u minus x square upon a square plus u x square upon this value becomes a square plus u whole square, and it's multiply to del u over del x. On differentiating second term, here y square is constant, so take out because it is partial differentiation, so we have to only differentiation only 1 upon v square plus u, which is like as this term. So I write it as this term because same it is same calculation like second term, because y square is constant and v square plus e to the power minus 1, all the steps will same, but replace x as a y and a as a v. Replace a to v and x and y. We will get this term like this. So it is a negative term. So I write here minus y square upon v square plus u whole of square del u over del x. Also for on differentiating this term we get this term minus z square upon b square plus u whole of square del u over del x. On differentiating right hand side we get equal right hand side of equal sign is 0, differentiation of 1 is equal to 0. We can take common out from these three terms. These terms are negative, so take out minus from bracket. Write this term first, 2x upon a square plus u, and take minus from these three terms. Then in bracket all terms will be positive, and also we take out del u over del x, and I will write it on the right hand side. So we get x square upon a square plus u whole of square, and in this term we get y square upon b square plus u whole of square plus z square upon v square plus u whole of square, and del u over del x, and on right hand side it is 0. I want to now value of del u over del x because in proving of this relation it is necessary because it will use in 2 times here, and similarly del u over del y and del u over del z. But first we want to find the value of this, so I transport it on the right hand side. We get on left hand side which is 2x which is 2x upon a square plus u, and on right hand side we get it becomes x square upon a square plus u whole of square plus y square upon v square plus u whole of square plus z square upon c square plus u whole of square, and del u over del x. If we find the value of del u over del x, then this will go to denominator of this value, so it becomes numerator. So I write del u over del x from this relation. So in numerator it is only 2x upon a square plus u. I write it in bracket, and this value is in denominator, x square upon a square plus u whole of square plus y square upon v square plus u whole of square plus z square upon c square plus u whole of square. Similarly, we can find the value of del u over del y. We can, I write similarly we can write del u over del y. Only we have to replace x by y, and also a replaced by v square. So I write value of there is no change in this, because this value is symmetrical about x, y and z. So all cases this value are same. A square plus u whole of square plus y square upon v square plus u whole of square plus z square upon c square plus u whole of square. For convenience of writing this value, you can use a sigma by writing first term or any term and write sigma before it. But I write all value for sake of understanding of students. All three value which will we will use in proving. So I write this value, and we have to prove this. So when we write this value, it becomes this value. So I write it first, and then we find this value and make it to equal to this value. So I write it so that I write this value. So first of all, I am trying to making right hand side, so leaving 2 and only write this value, because 2 is constant. We can multiply to any time. It is not any problem. So I write only this value, and all terms are very big. So I write directly here. This value is you are seeing here. When it will multiply to x, x will multiply only in numerator, and its numerator and also its numerator. This value, so this becomes then this become 2x square. When I multiply x here, this multiply to only here. So this value becomes 2x square upon a square plus u. It is numerator and denominator is same, but here we have to write all three terms, but I write only 2 terms here. So we have to write also third term. So I write third term also, because we have to need here this value. So I write similarly this value and and del u over del z. I commit a mistake here. 2z over c square plus u, because y replaced by z and b replaced by c. All these values are same. We can write it as x square upon a square plus u whole of square plus y square upon v square plus u whole of square plus z square upon c square plus u whole of square. Because we have to find this value, but there is no such space for writing these three terms, so we need a trick, which I also say you that we can use writing this value by applying sigma before any of this term. So I write sigma before this term, and we can write it in briefly. So numerator is 2x upon a square plus u. I don't change in this writing this value. What you can write it whole or write it as I write sigma and apply before this term. If any problem this, you can ask me. I use this term because sigma means first term, like write as it and apply plus and replace x to x by y and a by b, and then plus apply plus sign because it is sigma, and y replaced by z and b replaced by c, because this sigma is for x by z and a b c, but it is not necessary to write here. So I also write this value in brief by using sigma. So del u over del y equal to 2y upon b square plus u. It is numerator, but I write denominator as it. Applying these values are equal, so I write this value for this denominator means x square upon a square plus u whole of square. Also in brief notation we can use del u over del z. It will help in our writing. So write in brief c square plus u and sigma x square upon a square plus u whole of square. As I already say that we have we will find this value first. So I write x del u over del x plus y del u over del y plus z del u over del z. Now we will put the value of these which we have find here and here. So write these values on multiplying x, y and z respectively. On multiplication of x here, this x multiplied here, it become 2x square and all value is same. So I write directly here 2x square upon a square plus u upon sigma x square upon a square plus u whole of square, and also this term, for this term y, on multiplying y here it becomes y square here. Then we write 2y square upon b square plus u, all value will same, sigma y square x square upon a square upon u whole of square. Also for finding this value z should multiply here and here, it will become z square. So I write here 2z square upon c square plus u whole upon sigma x square upon a square plus u whole of square. Here we are seeing these value are same, which is in denominator. So I write it is only 1 times sigma x square upon a square plus u whole of square, and all this value will sum of 2x square upon a square plus u plus 2 times y square upon v square plus u plus 2 times z square upon c square plus u. On taking out 2 as a common out from these, we get 2 take out common, and we get x square upon a square plus u and y square upon v square plus u plus z square upon c square plus u, and write denominator as it x square upon a square plus u whole of square. We are saying that this relation is given relation. It is nothing it is nothing but equal to 1. So I write this value equal to 1, which is given. So use the given relation, we can write this value as 1. So and on left hand side we are finding this value, which is equal to x del u over del x plus y del u over del y plus z del u over del z is equal to 2 into 1 upon sigma x square upon a square plus u whole f square. If we write this value as equation 1 in starting, so we can write here as using equation 1 here, using equation 1, because I write this value equal to 1 here. So it is equal to it is equivalent to right hand side only 2 we have to only 2 multiply here, which will come right hand side. 2 is we will constant, so we will manage to first now we should find the value of these 3 terms. So write del u over del x so whole of square plus del u over del y whole of square plus del u over del z whole of square. Put the value of these in brief notation. So we should write del u over del x equal to this value, which is in brief notation. So I write in numerator 2x upon a square plus u, which is in numerator, and in denominator its value is sigma x square upon a square plus u whole of square, it is whole of square. Now write this 2 value also. I write this value from previous calculation, and also write this value, which is 2y upon b square plus u, and denominator is same, x square upon a square plus u whole of square, but it's whole of square here, plus because it is 2 whole of square. And now we will write this value, which is equal to 2z upon c square plus u upon sigma x square upon a square plus u whole of square. This square we will write here. Now we have to calculate this. First of all, we should open this bracket, then it becomes numerator square and also denominator whole of square. So I write numerator 2x upon a square plus u, and denominator, which is sigma x square upon a square plus u whole of square it is value and whole of square. And also write like this terms, numerator is square 2y over v square plus u whole of square, and denominator is square. Denominator is this value, so I write sigma x square a square plus u square whole of square plus also in this term new whole of square, open this whole of square, then numerator square upon denominator square, 2z upon c square plus u, and sigma whole of square and sigma x square upon a square plus u whole of square. Here we use a formula, numerator by denominator whole of square is equal to numerator square upon denominator square. It is a simple formula. We are seeing that all the denominator and all fraction are equal, so take it LCM sigma and write and add up these three fractions, x square a square plus u whole of square, whole of square whole value, and then since these are equal, so write add up this directly. So write this value first, which is 2x upon a square plus u whole of square plus 2y upon b square plus u whole of square plus 2z upon c square plus u whole of square. Now we can open this bracket, and then 2 square becomes 4 and x square becomes x square, and this value is a square plus u whole of square plus 4y square upon b square plus u whole of square plus 4z square, opening this bracket, 4z square upon c square plus u whole of square. There is no change in denominator, so write it is as it, x square upon a square plus u whole of square, and also whole value whole of square. Take out 4 from this bracket. We can write 4 and 4 and in denominator there is no change, so I write denominator first, sigma x square upon a square plus u whole of square, and this also whole of square, and take out x square from these three terms, then in bracket we get x square a square plus x u whole of square plus y square upon b square plus u whole of square plus z square upon c square plus u whole of square. What it is not value other than sigma this value or this value, so I write with this symmetrical about x by z, so we can use it in sigma notation, so I write only sigma in first term, apply before sigma first term, and I'll add up this value, we get 4 times I apply sigma in first term, x square upon a square plus u whole of square. This value is nothing but equal to this value in like term, what it is in denominator it is a whole of square, so 1 degree this value is same, but this is a whole power, but is 1 power, so 1 power is cancel out, so only 1 power will remain in here, so this value is this value, which is equal to this value, we get del u over del x plus del u over del y, this value which is equal to this value, I write and solve this value, and after solving we get this, so this value is equal to del u over del z whole of square equal to this value, which is 4 in numerator, and here only 1 power, so it is not need to write sigma 1 power, so sigma x square upon a square plus u whole of square. Now we will find we will use this value. We will connect we want to connect that value to this value, because it is appear in right hand side in proof. So this value, which is nothing but 2 upon sigma x square upon a square plus u whole of square. So I write it as equation number 2, which is equal to this value, means x del u over del x plus y del u over del y plus z del u over del z, which is in previous lines. After for solving this value, we get this here. I write it as equation number 2, and I will use here, because 4 we can write 4 as 2 into 2, and 2 upon this value sigma x square upon a square plus u whole of square. It is value of from equation number 2 is nothing but equal to this value, which is x del u over del x plus y del u over del y plus z del u over del z. So now we have proved del u over del x whole of square plus del u over del y whole of square plus del u over del z whole of square is equal to 2 times x del u over del x plus y del u over del y plus z del u over del z. Thank you very much indeed for listening me. Wa akhiru da'wana alhamdulillahi rabbil alamin.